Okay, so now we're going to think about dividing polynomials. Okay, so I to kind of get your head around what we're trying to do here, I'm going to use a really simpler example. So if I asked, can you divide 38? Can you divide that by 6? Okay. Well, we know that 6 doesn't go into 38 perfectly. So, what we'd be used to saying is, 38 divided by 6 will be, we usually put this into a calculator or something, and we'd have it as 6.3333 or something like that. But, way back when we were first learning to divide, we'd use remainders. So we know that 6 times 6 equals 36. So there's going to be and we know that there's a difference of 2 here. So we could say that it goes in 6 times with a remainder of 2, right? So another way of writing this was when we have this full expression, we know that 38 is equal to 6 times 6 plus 2, okay? So when we're thinking about polynomials, we're going to have these new terms, okay? So we've got a term here, right? This is what we're going to be dividing by. This is going to be called the divisor. It's just like, because that's the one dividing. That's the divisor, okay? And then we're going to have this term here called the remainder, which makes sense. It's what's left over, or from the divisor acting on this action here. So this is the remainder. Yeah. Okay, but what about this term here? This term here is called the quotient. Q-U-O-T-I-E-N-T. Okay, and basically what that is that's what is acted upon by the divisor and whatever is not included by the remainder. So if I look at this expression here and I say I want to divide this polynomial by x plus 2. Okay, well how am I going to do that? Okay, well, what you first need to think about is this is a great example of when synthetic division becomes really useful. Okay, well, instead of thinking of this x minus 2, well, this is the factor, so why don't we think about what the root would be? So this minus 2 is going to become positive 2, because x minus 2 equals 0, so x equals 2. That's the logic behind it. Okay, when you set up your synthetic division, you have it here, so you've got a 2 here from there, and then you just want to take your coefficients and line them up. So this is 2, and then x squared is 1, x is 2, and then the last term is 3. Okay, so 0 goes to 2, 2 times 2 is 4, 4 times 1 is 5, 5 times 2 is 10, 10 plus 2 is 12, 12 times 2 is 24, 24 plus 3 is 27. 27. So what we want to do now is write a new expression out with this information, okay? So basically we want to write out what the factors of this expression are. Well, not the factors, because we'll get onto that later. But we want to be able to write it out. So if you multiplied it backwards, you'd get the same answer. So you'd have x minus 2, right? And what's going to be here? Well, what's happened here is you actually take this down by one order. This expression gives you the result to a new order. So instead of being x cubed, this is now x squared. So this becomes x squared plus 5x plus 12. Okay, and now you've got this here in the wee half box. That's the remainder. Okay, that's what's left over afterwards. It's 27. So labeling everything, we divided by x minus 2, so this is the divisor here. This is what's acted upon by the divisor here. This is the quotient. Okay, and here is I'm just going to abbreviate these. So this is the quotient, and this is here is the remainder. Okay, so this now becomes important because we're going to go on to talk about something called the remainder theorem, and why we're learning all this will become a bit more clear.